Okay, and moving on. So in other situations, it's easier to find the probability of the opposite of what's being asked first, called the complement. So if we talk about the probability of an event happening, we might talk about the probability of some event happening. Then the probability of that event not happening would be listed as probability of A with the bar on top. So probability of A is the probability that it happens, or it occurs, and the probability of A bar, probability of not A, is the probability here that it doesn't occur. They're complements. When those two things are their exact opposites, they will always add to equal 1. So the probability of A plus the probability of it not happening, of A not happening, is always equal to 1. And we're going to use that. We're going to use that in this experiment. So let's say that we're tossing 2 coins, and we want to find the probability of getting at least 1 head. We could make another kind of diagram of all the outcomes, called a Venn diagram, and we'll get into that a little bit more shortly, where you have heads, that's one option. You could have heads, tails. You could get tails, heads, or you could get tails, tails. So if we're trying to find the probability of some event, we should be able to take 1 minus the probability of it not happening. So if I go with that, the probability of at least 1 should be equal to 1 minus the probability of no heads. Well, no heads only happens once. Out of all the 4 outcomes, it only happens once. So the probability of at least 1 head is equal to 1 minus 1/4, 1 out of 4, or 3/4. And that works out. We can see it here in this simple example because there are 3 ways that we get at least 1 head. So you might think, well, what's the point of doing it that way? Well, the point is, if we're looking at something with 6 coins, now imagine trying to make all of the possibilities, all the possible outcomes. Remember what I said? The outcomes, the size of the sample space was the number of outcomes for each part of the experiment. So with 2 coins, it was 2 times 2, or 4 outcomes in the sample space. With 6 coins, it's going to be 2 times 2, that's 4, 8, 16, 32, 64 outcomes. Well, I don't want to list them all, but if I want to find the probability of at least 1 head, again, that's going to equal 1 minus the probability of no heads. No heads only happens one way, if it's all tails. So the probability of at least 1 head with 6 coins is 1 minus 1 out of 64, the 64 possible outcomes, which was 2 to the power of 6, and 1 minus 1/64 is 63 64ths. So the probability of at least 1 head with 6 coins is 63 out of 64. It's like magic.